I like surf music, and some of my favorite surf music comes from Fallout Boy. And if you can name that tune, I will be impressed. But in any case, welcome to the OBX Wave Report and to a special edition of the OBX Wave Report, where I'm going to talk to you guys about something a little bit more serious than just surf music, something with gravitas, or that the major media outlets should be addressing with gravitas. Um, I tend to be a bit tongue in cheek. That's just the way I am. But but yeah, things are interesting and serious right now in the climate system. Serious in the sense that there's some serious discussions that should be had about what's going on. And here on the Outer Banks, we are experiencing pieces of what's going on. And I want to start out with this story. We're going to talk about the polar vortex smash, the Arctic warming that is the the main driver of the smash of the polar vortex. I'm calling it the smash because that's the way I think about it. It's like you got these warm winds coming up from the south, and there's some stuff going on in the upper levels of the atmosphere as well with the jet stream, and there's a cold core in the Arctic called the polar vortex, and the warm winds and the jet stream dynamics are smashing the polar vortex. And I'm talking about science. I'm talking about weather. I'm an observer. I'm an amateur observer. Go to the climate scientists. Listen to what they have to say. My reporting here is based on what the climate scientists are saying and what the weather models are saying. But listen to the experts. So Dr. Michael Mann, Dr. Jennifer Francis, and the other experts on polar vortex, climate change, all the stuffs. What I'm going to tell you about is what I saw, and both here on the Outer Banks and in just my daily wanderings through the science. So yesterday, I went to the beach and did our wave report thing where we observe the waves, and I encountered a surprise. I was like, not expecting this. And the reason why I was not expecting this was because typically when you get like a big blow from like a polar air mass, the winds shift around to the northwest and blow offshore. But we didn't get that. We did get that polar high coming down, but we also got this other thing. And I haven't really talked about this enough because it's like way, way out there, but I shouldn't be like forgetting the things that are far away that affect us. And the thing that's far away that's affecting us, the other thing that Dr. Michael Mann recently pointed out this morning and yesterday, is there's a big old nor'easter up there out at kind of the junction between Newfoundland and Greenland out there in the North Atlantic between the two, and it's a big old bomb cyclone nor'easter. And what that thing is doing is like for here in the Outer Banks, it helped to shift the wind from the northwest, associated with the high coming in more to a northerly and northeasterly fashion. And then what happened was when I got out onto the coast yesterday, there was a stiff northeasterly wind. I'm finding out now just looking at the the wind models from Jeanette's Pier that the winds kicked up to gale force out of the northeast. And I was saying, wow, this is like a nor'easter. And we were getting 40-mile-per-hour sustained winds yesterday afternoon and evening at Jeanette's Pier with gusts up to 50 miles an hour. And that's just nuts. That's crazy. That's nor'easter style conditions. And that driven by the winds getting smashed between this high pressure coming down from the north from the Arctic and this bomb cyclone low pressure way, way out there off of Newfoundland and Greenland, far away, like, 1,000 miles away or so, maybe more. And just the this big influence of these like huge forces moving through the world. And um, there's a climate change fingerprint on this, and it's kind of twofold. I'm looking at the research. I encourage you, reporters, experts, weather reporters, to read the data and give like a better, more granular analysis than I'm going to give. I'm just going to do the broad brush. But there's a warm wind event right now being driven by this nor'easter in the North Atlantic. It's dredging winds and air and heat up from the subtropics and the tropics, hurling it all the way up across the North Atlantic, across Greenland, across Iceland, across Svalbard, and smashing that air into the Arctic. And that's causing this big balloon, if you will, of warmer of warmer than normal air to expand over the Arctic at both the surface, and then you get the upper levels involved as well with this polar vortex smash. And when that warm air sits over the pole and invades the pole, the cold air that is typically centered there in the polar vortex gets smashed off. It gets broken off into pieces and it flies south. So it's like, you imagine like a like a swirl of like a confluence here, and it's got this, cold core, and then the warm air comes in, and it's just like smash, and then these pieces of the cold get hurled off like, I don't know. I kind of imagine this almost like a cosmic collision between like objects in space, and then there's kind of almost like a gravity there. That's almost what it seems like what's happening to me with these polar vortex excursions. You get this shot of warm air, and then this boom, and then this of the cold air that pirouettes off, and these cold cores that fragment from the polar vortex. They spin out and they spin down into the lower latitudes, and that's what happened. We got that smash, and then the boom, and then the pirouette of the pieces of the polar vortex that got broken off. And one of those pieces came hurtling down from the Arctic, down over Canada and down into the Northeast. And we got those warm winds coming up from the south. Well, then we also got those cold winds behind the bomb cyclone coming in from the north. And those cold winds and that cold air drove some crazy stuff. So this is what we saw in the Outer Banks. Now let's go to what we saw at Mount Washington. Let's get this here. All right, this is the National Weather Service from Cleveland, and last night. And they recorded some insane wind gusts. So remember, we got those wind gusts at Jeanette's Pier at 50. Well, up in Mount Washington, they got wind gusts up to 127 miles per hour in association with this thing. And this big weather system that like high, low pressure, massive confluence of air moving north across the Atlantic, severe nor'easter out there near the Newfoundland region, and mouth of Baffin Bay and into Greenland and running on up. And then behind it, you got that whip, that high pressure system moving in behind it, creating that tight packing of the isobars and temperature differentials from that hot North Atlantic air, warm North Atlantic air, and that cold smash coming down from the polar vortex. And boy, did it generate some crazy winds up there in Mount Washington of 127 miles per hour. And with that cold air and those strong winds, you got these crazy wind chills. Now, this reading, at NWS Cleveland was negative 101 degrees Fahrenheit, but it got even worse. It got all the way down to a wind chill of negative 108 degrees Fahrenheit at Mount Washington. And that due to both the wind and the actual temperature. Now, this was a record low wind chill for any place in the United States. Record low wind chill driven by polar warming and the polar vortex smash and the fragments of that North Pole cold careening off down into the lower latitudes. And I just cannot talk enough about the science that occurred that has given us an understanding of what's going on. So I'm going to go to Michael Mann, and he's the one that pointed this out to me, this scientific study. Um, and he says in his most recent tweet, this aspect of the current cold wave is important because it is emerging science suggesting human-caused climate change is leading to more intense nor'easters. So this is an aspect at the surface of weather that is related to what's happening at the higher levels in the atmosphere because it's like all connected. So there's these big polar vortex smashes coming from these warm air invasions that have been identified by scientists like Dr. Jennifer Francis and recently reported about by weather and climate journalists like Laura Pattinson. And here we have another aspect of these features because when you get so much air moving, when you got hot moving toward cold, and cold getting smashed and heading southward, you get cold next to hot. And that cold next to hot drives a lot of instability and extremes. And in addition to that, you got that warm moisture coming in off the Atlantic because the North Atlantic is much warmer than normal. You got that atmospheric lift, that convection, which helps to fuel those bomb cyclones. And so I encourage you to read this Dr. Mann piece of science. Dr. Mann identified piece of science from uh, the Department of Marine, Earth, and Atmospheric Sciences, North Carolina State University, Raleigh, North Carolina. And this one's from 2014 and 2015, entitled Changes in U.S. East Coast Cyclone Dynamics with Climate Change, identifying the effects of nor'easter, the effects on nor'easters in the North Atlantic from the warming Earth system, the Earth system, of course, warming driven by fossil fuel burning. Okay, so we're going to have to get some experts to talk more about that. Um, but what I want to do is I want to talk about this nor'easter and this thing up here. It's a kind of a beast. Okay, so let's just look at the present dynamics in the North Atlantic. And so right now, let's see, I'm going to try and find the center of this high pressure system. It looks like the center of the high pressure system is around 1040 millibars maximum pressure here. So 1040 millibar high is pretty beastly and pretty powerful. And then we've got this crazy double barrel, like a nor'easter kind of thing out here in Baffin Bay. And woo boy, we've got, and this is in the GFS or Earth null skull, so the actual pressures are probably going to be a bit lower. But we got this 956 millibar thing, and that's like hurricane strength right there. It's probably category 2, 3. Comparable intensity. Of course, this is a nor'easter type event, an ocean storm system type event. So it's spread across, like 1,500, 2,000 miles of water here. But so that's what we got. We've got two behemoths in the atmosphere fighting it out. And what's driving this? What's driving these behemoths? Let's look. Let's get down to temperature. Okay. So here what we've got is this movement of air. We've got this big old high here pulling down the Arctic air, and it's really cold. So let's get a cold reading here. Now we'll just say negative 28 degrees. So that's Celsius. Let's get into Fahrenheit. So negative 20 degrees Fahrenheit. Let's make sure this is now. Yeah, we're at now. That's over like the St. Lawrence. Negative 24, negative 25 over the St. Lawrence. Okay, so that's in one region. Now let's just get out here just past the Gulf Stream in this warm flow of air coming up from the subtropics. That's 68. So basically, 70 degrees out here off of New York, Massachusetts, and Rhode Island if you just actually more like the Delmarva. But we could just move it up off of New York, Massachusetts, and Rhode Island, just call it 67 degrees. So 67 degrees out here in the North Atlantic with that warm air mass moving north, and negative 20 degrees-ish over the St. Lawrence. So I don't know, let's do some math. That's a 90-degree temperature differential between the warm air mass and the Arctic air mass over a region that's, I don't know, let's see, that's about 700 miles. That's 90 degrees of temperature change over 700 miles. And smashed in between those two extremes, you've got these two behemoths of weather. So that's what's driving it. You've got this cold air coming into conflict with hot, and you've got these big weather behemoths that get spun up out of it. And let's just look. Let's look at these warm winds. So you got these warm winds moving up toward the north. They're encountering Greenland. They're flowing over Iceland. They're moving up just south of Svalbard. And this thing is going to dredge and push this punch of warm air even further into the Arctic. Already we've got this one punch that came in and displaced the polar vortex. And we got more of a punch coming in as this thing gets spun up. And let's also look at the wind speeds. I just want to show you the wind speeds out here over the North Atlantic in association with this nor'easter. Let's see, the wind. Okay, easy. All right. So in the frontal zone of the nor'easter, we've got winds in the range of 60 mile per hour sustained. And these 50 to 60 mile per hour sustained winds are over at least a fetch. So it looks like about 1,000 miles. Behind the system, you've got 50 mile per hour winds coming in from the northwest. And then near the center of this storm, let's look at this. Let's get in nice and close so that we can see where the most intense winds are and how strong they are. That's hurricane force wind speed. And this is in the model. The gusts are going to be much stronger than this. And this is over ocean. So about, this is hurricane force sustained winds out here in Baffin Bay in association with this bomb cyclone. And it's big. It's a huge beast of a thing. Let's look at the clouds. This is in the Earth Null School Monitor. This is total cloud war. Just look at this. This swath of clouds. Basically connecting moisture from the Gulf, from the North Atlantic off the eastern seaboard, forming this massive storm front here south of, stringing off south of Greenland, nightmare to the shipping lanes, and then this just beast in here in Baffin Bay. So yeah, I guess we could call this thing the Beast of Baffin Bay. 956 millibars bomb cyclone associated with the severe winds that we saw at Mount Washington. 127 mile per hour winds and a record wind chill. I want to talk about cold and hot. So every time these polar vortex excursions happen, you get this rash of morons talking about how climate change is not happening. But even as this is actually a fingerprint of climate change, as the polar vortex gets smashed. And I do want to point you guys more to the scientists about the polar vortex dynamics, because the way the upper atmosphere and the lower atmosphere interact is pretty complex process. But one of the telltales is where the heat is and where the cold is. And right now, I want to show you, this is an anomaly map from Climate Reanalyzer. And let's just see, did global warming end according to Climate Reanalyzer? And I wanted to get one that provided the information about the zones and the temperature anomalies. Hold on, I'm going to find another map. You're going to have to bear with me. Here we go. Let's look at the reanalysis maps. There we go. That's what I wanted to look at. Okay. And let's look at now. February 2023. Do we have it? Nah, it's not going to give me a 2023. Lame. Okay. Um, all right. I am going to have to do a Google. My apologies. Let's go with I want to look at the Arctic, and I'm going to go to a site called the Arctic Sea Ice Graphs site, and we are going to look at some anomalies by, let's see, here we go. Is it in the forecasts? Air temperature anomalies. I'm getting there. Do we not have the old graphs? Here we go. I believe this is it. Nope, sorry. I want to give you guys the oh, here we go. Karsten. Okay, so we're going to give a major shout out to Karsten Houston, and we're going to give you guys the global forecast system climate anomalies map for the Arctic in the current run, which is today. And let's look at the Arctic in the 0-0 model, which is going to give us a reanalysis of Arctic temperatures and Arctic ocean temperatures, and the anomalies in the Arctic. And right now, so temperatures in the Arctic are about 1 degrees Kelvin or 1 degree Celsius above normal. So for the Arctic, the global warming did not end. And I would be willing to bet that for today, the global temperatures are about 0.6 degrees Celsius, 0.5, 0.6 degrees Celsius above normal. That's the way it's been for the past few days. And we'll just go ahead and have to confirm that later. I will confirm that in a later OBX wave report. But right now, the Arctic is warmer than normal, and Greenland is much warmer than normal, and we're getting that warm air invasion from the south. And let's just make sure, yeah, this is February 2023. And then I want to run this model for you guys. I'm gonna go back. It's basically the same model. I'm gonna go back to the climate reanalyzer and look at the outlook maps for, I'm sorry, the forecast maps for the Arctic, the hourly forecast maps. And we're going to go to world, and you're seeing a little bit of like kind of what I do when I'm looking at all this crazy stuff. So let's look at the world. And the 2 meter. We're going to look at the 2 meter temperature anomaly, and I'm just going to show you the what's expected to happen for the Arctic over the next day or so. So we got those warm winds coming up from the south, and watch as what happens. So you got this big dig of this cold air moving over the Atlantic on the backside of our bomb cyclone nor'easter, and then on the east side, we've got this flow of warm air heading up into the Arctic that then balloons over the backside of Greenland and just fills up the Arctic. So watch this thing fill up the Arctic. It's just boom, it's injected into the Arctic, and then watch it pop. It just fills the higher latitudes. And it's just like this puff of hotter than normal air that has filled up the Arctic as the colder air has been smashed to the south. And you can see this. There is the warmer than normal air spreading out over the Arctic. And then looking at the more southerly latitudes in North America, in Europe, in Asia, you've got these regions of colder than normal air. And what's happened is the cold air, which is typically centered in the Arctic at this time of year, has been blasted off its throne, its safe haven, its stronghold, and is now a remnant of what it once was, scattered over the northern hemisphere. And where you are, it might be cold because a piece of the Arctic got hurled your way. But what's happening is a process of global warming where air is being transported from the tropics and invading the pole. And that's part of the process of polar amplification. But what it does is it creates these situations where we can get some extreme weather as the hot and cold come into conflict in areas where they wouldn't normally. And right now, where they're coming into conflict is over the North Atlantic in the form of this big, crazy bomb cyclone nor'easter. And so we've got that as well. Now, if you're a weather reporter and if you're like a climate scientist with like weather reporting chops, this is like the news of the day. Um, this big old nor'easter, this bomb cyclone, the Beast of Baffin Bay, is what's driving the -8 degree Fahrenheit wind chill at Mount Washington. It's been spun up by this polar vortex smash as a flood of warm winds press northward from the North Atlantic in front of this thing. It's like it's dredging it. It's like it's the massive scope of this nor'easter is pulling air up from the subtropics and hurling it toward the Arctic. And so for our closing, what I'm going to do is I'm going to look at the temperature map. And I just want to show you where the winds are going and how the warm smashes into cold over the next day or so as this bomb cyclone hurls the cold up. I'm sorry, hurls the warm up from the south. And the bomb cyclone doesn't seem to go away. It roars out of Baffin Bay. It roars toward Iceland. It rushes up towards Svalbard, and it sends out these massive waves toward the ice sheet, even as it hurls these warm winds. So you can see this flow of warm wind rushing up over Iceland by later today. And as we get into tomorrow, the south to north flow is covering, I mean, just look at this. You can see where the winds start just off of Spain here and run all the way up to Svalbard. So from Spain to Svalbard is at about 2.5, 3,000 miles. And then they rush out across the extreme North Atlantic and into the Arctic Ocean. And then they take a left turn north of Greenland here and drive this much warmer than normal air for this region. I mean, look over Svalbard here, like, or just south of Svalbard. The temperatures are 33 degrees, so above freezing at the Arctic Circle here with these warm winds in February, on February the 4th, February the 6th, February the 6th in the model, and then warming up as the warm winds continue to rush into the Arctic on February the 6th. And then we get this punch of near freezing and above freezing air that gets, into the ice sheet region here later on the 6th. And then you can see that front of warm air just moving in. And so all of it's just getting driven into the Arctic like a wedge of heat. And then let's just look at the wind speeds here. So the wind speeds rushing up from the south in the Arctic are in the range of 50 miles per hour. The wave heights, the significant wave heights, 12, 14, 18 feet, smashing into the ice sheet along with these warm winds. South of Iceland here, we've got 60-mile-an-hour winds. So these warm winds just howling out of the south, bringing that warmer than normal air into the Arctic, smashing it into the Arctic with gale and storm force. And let's look at the waves. And so you have those crazy significant wave heights in the 30-foot range off of Iceland. This is on the 7th of February. This is in the model. And these massive waves smashing into the ice sheets, 18-foot waves smashing into the sea ice. So that's what you got. You got this bomb cyclone nor'easter, these warm winds coming up from the south, warm air invasion smashing away at the polar vortex. This core of cold is getting warmed up. And then the remnant cold gets hurled off onto the continents. Um, and that's what we've got. Now, I'm very interested in the science here, the science that Dr. Michael Mann has posted. I'd like to hear more about this potential for intense nor'easters driven by human-caused climate change, and how it's linked with warm air invasions, these polar vortex excursions. I'm curious how well I portrayed the dynamics as an amateur observer and a science enthusiast and a surfer. I would love to see some weather experts talk about this because it looks very important to me. Uh, and so I'm going to leave you with this Michael Mann thought, and I'm also going to leave you with one last bit of data at the ocean. We're going to look at the sea surface temperatures, the sea surface temperature anomalies. Because the scientists have been talking about the hot ocean and how the ocean has sucked up a lot of heat from human-caused climate change. And just look at this. I mean, this is an anomaly map. So we don't have 1 degree Celsius temperatures out here in the North Atlantic. We got 1 degree Celsius above normal temperatures. That's 2 degrees Fahrenheit. But look at where the much warmer than normal ocean conditions are. It's like right here in the Gulf Stream, 6 degrees Fahrenheit above normal just off the Georgia, South Carolina coast. 5 degrees above normal out here in the Gulf of Mexico off of the Florida Panhandle. And look out here off the Northeast in the Gulf Stream, 11 degrees Fahrenheit above normal. And then out here in the Labrador Current, where it's supposed to be really cold, you got much warmer than normal conditions in the range of 6 to 10 degrees Fahrenheit. And out here in the North Atlantic, 11 degrees Fahrenheit above normal pools. I mean, these are hot spots, but even so, it's still crazy. So look at all that heat. It's almost like there's a prepped pathway for the heat to move toward the Arctic here in this warmer than normal environment. So it's like setting the ground for these bomb cyclones to occur. You've got this prepared temperature differential and all this extra moisture that's getting pushed off of the North Atlantic. And then with the upper levels of the atmosphere generating these big waves in the jet stream, you got that hot next to cold. And then these warm air invasions just swoop on in. All right, so thank you for joining me for this special edition of the OBX Wave Report. It is connected to waves, and We saw that yesterday with this massive nor'easter, this beast of Baffin Bay hurling unexpected large swells here at the Outer Banks. Gale force winds at Jeanette's Pier. Again, unexpected. There was no gale warning here. There was just small craft advisories. And you know what? I want to show you the confirmation of the winds at Jeanette's Pier because I've been talking about it. So here is the observations for Friday, February the 3rd for wind conditions at Jeanette's Pier. And the blue line were the sustained wind conditions, red line the gusts. And so at 10:15 p.m. we had a gust of 53 miles per hour with sustained winds in the gale force range. So we got a gale here on the Outer Banks, and that was not predicted. We just had a small craft advisory, and this is what I saw yesterday. This craziness hurled out of the beast at Baffin Bay, the bomb cyclone up there. Spawned by warmer than normal North Atlantic, likely, and warm air invasion of the Arctic, smashed polar vortex, set off all kinds of crazy stuff. One of the main upshots being the crazy wind chill we got at Mount Washington in the negative 108 degrees Fahrenheit range as serious winds got hurled out behind that bomb cyclone nor'easter, and the cold air in the Arctic got smashed and splinters of it careened southward. So thank you for joining me for this edition of the OBX Wave Report. I encourage you to go back to the scientists and the weather experts and find out more. I'm listening to the scientists. I'm talking about it. Please do the same. Thank you for joining.